Hi, my name is TTJ Kepsi Richard and welcome to my YouTube channel. Today our discussion on calculus of several variables, which people also refer to as vectors analysis, will be on a very important property of vector value function, which is the derivative or the dot product of a vector value function. Before the video ends, we'll learn how to find the dot product of two vectors. We'll also learn how to find the dot product of two vector value functions. Then we'll find the derivative of the dot product of two vector value functions. This will be a very interesting engagement, so please be my guest. So when we talk of dot product, it simply means that the I component of the two vectors will multiply each other plus the j component of the two vectors multiply each other plus the k component of the two vectors multiply each other. Thus, if we want I dot I, it means that the j and the k component of these vectors are missing. So we can have 1, 0, 0 as the vector, dot 1, 0, 0 as the other vector. So I dot I means 1 times this one plus 0 times 0 plus 0 times 0. Say 1 times 1 plus 0 times 0 plus 0 times 0. So we have 1 plus 0, which is equal to 1. So we can say I dot I is equal to 1. The same way, if we have I dot j, it means that this vector will be written as 1, 0, 0. Dot, this will be written as 0, 1, 0. So we find a dot product. 1 times this 0, 1 times 0, plus 0 times 1, then plus 0 times 0. 1 times 0, 0. 0 times 1, 0. 0 times 0, 0. So we can say I dot j is equal to 0. So what is the implication? The implication is that I dot I is 1. I dot j is 0. Then I dot k is also 0. Then j dot j will be equal to 1. J dot I will be equal to 0 and j dot k will be 0. Then k dot k will be equal to 1. K dot I will be equal to 0. Then k dot j will be equal to 0. So, if the dot product of two vectors is equal to 0, it means those two vectors are orthogonal. Please, very, very important, keep it. If you want the dot product of two vectors is equal to 0, that means those two vectors are orthogonal. Now, how do we find the dot product of two vectors? So, for instance, if you are given two vectors like this, vector A is 3i plus 4j plus 5k, and vector B is 2i minus 3j plus k, and we are asked to find A dot B, or A dot B will be equal to the vector A, 3i plus 4j plus 5k dot 2i minus 3j plus k. So, remember, the components will multiply each other. So, you have 3 times 2, then I dot I. Then plus 4 times negative 3, then j dot j. 4 times this negative 3. Then plus 5 times, remember, is 1 here, k dot k. 3 times 2 is 6. I dot I, remember, is 1. 4 times minus 3 will be minus 12. J dot j, remember, is 1. Then 5 times 1 is 1. K dot k is 1. So this will be 6 minus 12 plus 5. 6 minus 12, that's negative 6 plus 5 will be negative 1. Then we can say A dot B is equal to negative 1. So since we know that I dot I is 1, j dot j is 1, and k dot k is 1. We will choose to ignore, or we can choose to ignore. So for instance, if we have these two vectors, vector u equal to 6i minus 4j plus 2k, and vector v is 3i plus 2j plus 4k, and we are asked to find u dot v. How do we do that? Our u dot v will just be 6 times 3, 6 times this 3, plus negative 4 times 2, then plus 2 times 4. 6 times 3, 18. Negative 4 times 2 minus 8. 2 times 4 will be 8. Negative 8 plus 8 is 0. We left with 80. So we can say our u dot v is equal to 80. In the same vein, if our vectors involve a vector value function, for instance this, two vector value function, for instance u of t is equal to 3ti plus 4t squared j plus 4t plus 1 in k direction, then v of t is equal to 3t squared plus 3j minus 5t in the k direction, and we are asked to find u of t dot v of t. It will be equal to the first one, which is u of t, that's 3t in the I direction plus 4t squared in the j direction, then plus 4t plus 1 in the k direction, dot v of t, and our v of t is 3t squared in the I direction plus 3j, then minus 5t in the k direction. So remember, the components will multiply each other. So we have 3t times 3t squared, then plus 4t squared times 3, then plus 4t plus 1 times minus 5t. So how do we do that? 3t times 3t squared will be 9t cubed. 4t squared times 3, that will give us 12t squared. 4t minus 5 times 5t will be minus 20t squared. Then minus 5t times 1 will be minus 5t. So we have 9t cubed. 12t squared minus 20t squared will be minus 8t squared. Then minus our 5t. Then we can say this is our u of t dot v of t. I hope you get that. Now, how do we find the derivative of the dot product of two vectors? A very important property when it comes to a vector value functions. So for instance, we have two vector value functions, u of t and v of t, and we are asked to find the derivative with respect to t of the dot product of the two vectors. What will it be equal to? It will be equal to a very important, we'll use a very important rule in calculus, which is product rule, to do this. So remember product rule. We'll keep v of t and differentiate u of t, then plus. Now we'll keep u of t and differentiate v of t. So this will be equal to the dot product of the derivative of the dot product of these two vectors will be v of t dot u prime of t, then plus u of t dot v prime of t. So remember, we learned the derivative of vector value function. Please check out my videos on derivative of vector value function. We just differentiate, then we substitute the necessary tools. Then we simplify to find the derivative of the dot product of the two vectors. So now we take some sample questions and see how we deal with it. So for instance, we are given two vector value functions such as u of t equal to 3ti minus t squared j, and v of t equal to 2t squared I plus 3j. And we are asked to find the derivative of the dot product of the two vectors. How do we solve that? So the derivative Remember, of the dot product of the two vectors, u of t dot v of t, we said it will be equal to v of t dot u prime of t, then plus u of t dot v prime of t. Now, what is our u of t? Remember, our u of t is equal to 3t in the I direction minus t squared in the j direction. Then v of t is equal to 2t squared I plus 3j. Now we find the derivative of each of them. The u prime of t, that's the derivative of u of t, will be equal to, this will be 3i minus 2tj. Then v prime of t will be equal to 4ti. Remember, this is constant. One differentiate is 0 times j will be 0. So we'll be left with only 4ti. So we can just substitute, then we simplify to find our derivative. So our d of u of t, the derivative of the two, that, remember, we say is equal to this. So what's our v of t? V of t is 2t squared I plus 3j dot u prime of t. U prime of t is 3i minus 2t in the j direction, then plus, remember u of t. U of t is 3t I minus t squared in the j direction, then dot v prime of t, which is 4ti. Remember, the j direction or the j component there is 0. So now remember how to dot two vectors or two vector value functions. The I components will multiply plus the j component multiplying. So we have 3 bracket 2t squared, then plus 3 times minus 2t for the first bracket plus the second bracket. We have 3t times 4t, then minus t squared times 0, because the j component for this is not there. When we simplify, 3 times 2t squared will be 6t squared. 3 times minus 2t, that will be minus 6t for the first bracket. Then plus, this will give us 12t squared. Then this will be 0. So, we can just add the like term, 6t squared plus 12t squared, then minus 6t. When we simplify, that will be 18t squared minus 60. And we can say the derivative of the dot product of the two vector value function u of t and v of t will be equal to 18t squared minus 60. So we'll solve another example on this so that you'll be abreast with the concepts. So let's solve our second example. They say given that two vector value function u of t is equal to 6t plus 8 in the I direction plus 4t squared plus 2t minus 3 in the j direction plus 5t in the k direction, and the second vector value function v of t is equal to t squared minus 3 in the I direction plus 2t plus 4 in the j direction, then plus t cubed minus 3t in the k direction. We should calculate the derivative of the dot product of the two vectors. So how do we do that? Remember, the derivative of the dot product of the two vectors u of t and v of t is giving us v of t dot u prime of t, then plus u of t dot v prime of t. Now, what's our u of t? U of t is giving us 6t plus 8 in the I direction, and plus 4t squared plus 2t minus 3 in the j direction, then plus 5t in the k direction. and our v of t is giving us t squared minus 3 in the I direction plus 2t plus 4 in the j direction, then plus t cubed minus 3t in the k direction. Now we differentiate each of them. Our u prime of t will be equal to, when we differentiate this, we get 6 in the I direction, then plus, we differentiate this, we get 8t plus 2 in the j direction, then plus 5k. The differential of a linear term is just the coefficient of the variable. Then we find our v of t2, that's v prime of t, will be equal to, when we differentiate it, we get 2t in the I direction, then this will be 2 in the j direction, plus this will be 3t squared minus 3 in the k direction. So what do? We substitute and simplify, then we'll be able to find the derivative of the dot product of the two vectors. So remember, our v of t. What's our v of t? V of t is giving us t squared minus 3 in the I direction plus 2t plus 4 in the j direction, then plus t cubed minus 3t in the k direction, dot u prime of t. What is our u prime of t? 6i plus 8t plus 2 in the j direction, then plus 5 in the k direction, then plus u of t. What's our u of t? U of t is giving us 6t plus 8 in the I direction, then 4t squared plus 2t minus 3 in the j direction, then plus 5t in the k direction, then dot v prime of t. And what's v prime of t? That's 2t in the I direction plus 2 in the j direction, then plus 2t squared minus 3 plus 3t squared minus 3 in the k direction. So now we dot each of the components correctly, then we simplify and add. So the first bracket, when we dot, this 6 will multiply this, we'll have 6 bracket t squared minus 3, then plus this will multiply that, so we have 2t plus 4, then times 8t plus 2. Then the 5 will also multiply t cubed minus 3t plus the second bracket, 2t will multiply 6t plus 8, then plus 2 will multiply 4t squared plus 2t minus 3, then 5t will also multiply 3t squared minus 3. Now we simplify and add. So the first bracket, when we do this, we'll get 6t squared minus 18, then plus, this will give us 16t squared, then this times this will be 40, 4 times 8, that will be 32t, then plus 4 times 2 is 8, then plus, this will be 5t cubed minus 15t for the first bracket, then plus the second one, this will give us 12t squared, then plus 2t plus times 8, that will give us 16t, then plus 8t squared plus 4t minus 6. Then this times this will give us 15t squared minus 15t. So we group like terms from the highest power. The highest power for the first bracket is 5t cubed. Then we have 6t squared plus 16t squared. Then we have the linear, which is 4t plus 32t minus 15t. And we have minus 18 plus 8 for the first bracket. Then plus the second bracket. The highest power here is 3. So we have 15t cubed. Then we have plus 12t squared plus 8t squared. Then plus 16t for the linear. Then plus 40 minus 5t. Then minus 6. Let's count 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. We are through. So we simplify the first bracket. What are we getting there? We get 5t cubed, 6t squared plus 16t squared. That will be equal to 22t squared. Then 40 plus 32t. That will be 36t. 36 minus 15. That will be 21t. Then minus 18 plus 8. That will be minus 10 for the first bracket. Then the second bracket. We have 15t cubed, 12t squared plus 8t squared. That will give us 20t squared. 16t plus 40, that will be 20t minus 5t, that will be 50 plus 15t, then minus 6. Now we add like terms. 5t cubed plus 15t cubed, that will give us 20t cubed. Then 22t squared plus 20t squared will give us 42t squared. 21t plus 15t, that will give us 36t. Then minus 10 minus 6, that will be minus 16. So let's correct. If you check, this is 15t. This is 15t. So when we correct 16t plus 40, 20t minus 15t, that will give us 5t for this. Sorry for that. Then 5t plus 21t, that will be 26t for that one. So let's check it well. So we can conclude that the dot product of the derivative of the two vectors is equal to 20t cubed plus 42t squared plus 26t minus 16. Please check that well. When we are here is 15t, but I wrote 5t when I was solving. So we check it well. So let's look at our third example. The two vector value function u of t is giving us 2t minus 1 in the I direction plus 2t squared minus 4t plus 1 in the j direction plus 60 in the k direction. And the second one, v of t is giving us t squared minus 4 in the I plus 4t minus 5j plus t cubed minus 60k. And we are asked to find the derivative or the dot product of the two vectors. So remember, the derivative of the dot product of the two vectors, u of t dot v of t, will be equal to v of t dot u prime of t, then plus u of t dot v prime of t. So remember, our u of t is giving us 2t minus 1 in the I direction plus 2t squared minus 4t plus 1 in the j direction, then plus 6t in the k direction. And our v of t is equal to t squared minus 4 in the I direction plus 4t minus 5 in the j direction, then plus t cubed minus 6t in the k direction. So now we find the derivative of the two vectors. So u prime of t will be equal to, the derivative here will be 2i, then plus this will give us 4t minus 4 in the j direction, then plus 6 in the k direction. Then when we differentiate this one, we get 2t in the I direction, plus 4 in the j direction, then plus 3t squared minus 6 in the k direction. So now we can just substitute. So we can say that the derivative of the dot product of the two vectors will be equal to v of t. What is our v of t? V of t is giving us this. So we can say that's t squared minus 4 in the I direction, then plus 4t minus 5 in the j direction, then plus t cubed minus 6t in the k direction, dot v u prime of t. And what's our u prime of t? That's 2I plus 4t minus 4 in the j direction, then plus 6 in the k direction, then plus our so all this is for this, then this u of t, that's 2t minus 1 in the I direction, plus 2t squared minus 4t plus 1 in the j direction, plus 6t in the k direction, dot the v prime of t. And what's v prime of t? That's 2ti plus 4j, then plus 3t squared minus 6 in the k direction. What do? We dot the two variables, simplify and add the necessary things. Okay, so now we dot. So the first bracket, when we dot, 2i, the 2 will multiply this. So we have 2 bracket t squared minus 4 for the first one, then plus 4t minus 5 will multiply 4t minus 4, then plus 6 will multiply t cubed minus 6t for the first bracket, then plus the second bracket. So plus our second bracket, what are we having? 2t will multiply that, so we have 2t bracket 2t minus 1 in the I direction, then 4 will also multiply that, so we have 4 bracket 2t squared minus 4t plus 1, that's in the j direction, then 6t will also multiply 3t squared minus 6. So what do? We expand and simplify. So now we expand the first bracket. What are we having there? 2 times this will give us 2t squared, then minus 8. Then we expand this one. 4t times 4t will give us 16t squared. 4t times minus 4 will give us minus 16t. Then minus 5 times 40 will give us minus 20t. Then minus 5 times minus 4 will give us plus 20. Then we expand this one too. We'll get 6t cubed minus 36t. Then plus the second bracket. This times this will give us 4t squared. This times this will give us minus 2t. Then this will be 8t squared minus 16t plus 4 for the expansion of that. Then plus 6t times 3t squared, that will be 18t cubed. Then minus 36t. So we rearrange, we group like terms, then we add. So the highest power for the first bracket is 6t cubed. Then this second term square, so 2t squared plus 16t squared. Then the linear term minus 16t, then minus 20t, minus 36t. Then minus 8 plus 20. Then the second bracket too. The highest is 18t cubed. Then followed by the linear term, which is 4t squared plus 8t squared. Then we have that's the square term. Then the linear term minus 2t minus 16t minus 36t. Then we have plus 4. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So we are true. Now we add. So the first one, we have 6t cubed. Then 2t squared plus 16t squared, that will be 18t squared. Then minus 16t minus 20t, that will be minus 36t. Minus 36t will be minus 72t. Then minus 8 plus 20 will be plus 12 for the first bracket. Then plus our second bracket, we have our 18t cubed. Then we have 4t squared plus 8t squared. That will give us 12t squared. Then we have minus 2t minus 16t. That will be minus 18t minus 36t. That will be minus 54t. Then plus 4. So now we just add the light term. 6t cubed plus 18t cubed. That will give us 24t cubed. And have 18t squared plus 12t squared. That will be 30t squared. And minus 72t minus 54t. That will be minus 126t. Then 12 plus 4, that will be 16. And we can say that the derivative of the dot product of u of t and v of t will be equal to 24t cubed plus 30t squared minus 126t plus 16. I hope you get that. This is very simple. We solve one more question on this so that you'll be abreast with every aspect of the dot product, the derivative of the dot product of two vector value functions. So let's look at the next one. So they say evaluate the derivative of r of t dot r prime of t, given that r of t is equal to cos ti plus sin tj minus e exponent 2tk. So before we do that, please, did you subscribe to my YouTube channel yet? If no, I beg of you, please do. It is the only way you can help promote my YouTube channel so that I can record more mathematical content with you when my YouTube channel grows. How do we solve this question? Remember this one, there is only one vector value function given. However, we are asked to find the derivative of the dot product of the vector and its derivative. Very interesting. So we can say that the derivative of the dot product of the derivative of the vector value function, that's this, will be equal to, remember when we're doing two vector value functions, we keep one and differentiate the other. So let's keep r prime of t. Don't keep r prime of t dot the differential of r of t, that will be r prime of t, then plus, now what are we keeping? Now we'll keep r of t and differentiate r prime of t, that will be r prime prime of t. Very interesting, right? So what is our r of t? Our r of t, the vector value function, is giving us cos ti plus sin tj, then minus e exponent 2t in the k direction. Now what will be our r prime of t? That's the first derivative. Remember how to differentiate trigonometric function. Please check out my videos on the differentiation of trigonometric identities on YouTube. So now we'll differentiate it. We'll get negative sin ti plus cos tj, then minus 2e exponent 2t in the k direction. And then our r prime prime of t will be equal to. So our r prime prime of t, now we differentiate this, the r prime of t to get r prime prime of t. This, the differential of sine t will be, remember, will be cos t. So cos t I, and the differential of cos t is minus sine t, so minus sine t j. Then remember, we just differentiate the exponent, use it to multiply as usual. We get minus 4 e exponent 2t in the k direction. Now, what do? We just substitute to simplify. So the derivative of r of t dot r prime of t will be equal to, remember we said it's r prime of t dot r prime of t, then plus r of t dot r prime prime of t. So what is our r prime of t? Is minus sine t I plus cos t j, then minus 2e exponent 2t in the k direction, dot our r prime of t again. So the same thing, we have minus sine ti plus cos tj, then minus 2e exponent 2t in the k direction, then plus the second one, which is r of t dot r prime prime of t. And what is our r of t? Our r of t is cos ti plus sine tj, then minus e exponent 2t, then dot r prime prime of t, and r prime prime of t is minus cos ti minus sine tj, then minus 4 e exponent 2t in the k direction. So now we dot the necessary things, then we simplify and add. The first one, sine t, minus sine t times minus sine t will be sine square t. Remember, I dot I will be 1, so we don't have problem with that. Then cos t times cos t will be cos square t. Then minus 2e exponent 2t times minus 2e exponent 2t will be plus 4e exponent 4t using indices. Remember that. The 2 multiply 4. Then e exponent 2t times e exponent 2t. That will be e exponent 2t plus 2t. Remember that it will be e exponent 4t. That's why we have 4 e exponent 4t for the first bracket. Then plus this minus cos t times cos, minus cos t will be minus cos square t. Then sin t times minus sin t will be minus sin square t. Then minus e exponent 2t times minus 4 e exponent 2t will be plus 4 e exponent 4t. Remember that. So now, remember sin square t plus cos square t is 1. So 1 plus 4 e exponent 4t. Then plus, what is common here? Negative 1 is common, we bring it out. You have cos square t plus sin square t plus 4 e exponent 4t. You have 1 plus 4 e exponent 4t for the first bracket, then plus cos square t plus sin square t is 1 times minus 1 will be minus 1 plus 4 e exponent 4t. Now we add the necessary things. 1 plus minus 1 will be 0. Then 4 e exponent 4t plus 4 e exponent 4t will be 8 e exponent 4t. And we can say this is the derivative of r of t dot r prime of t. I hope you get that. So before we end today, we will look at a very important theory in vector value functions. So they say that the theory says that if r of t, which is a vector value function and is differentiable, and the magnitude of r of t is constant, It's a constant. It doesn't involve any variable. Then you can say r prime of t, that's the differential of r of t, is orthogonal to r of t for all values of t. Remember we said that when two vector value functions are orthogonal to each other, then their dot product is 0. So we can say that if r of t is differentiable and the magnitude of r of t is constant, then r prime of t is orthogonal, means that r prime of t dot r of t will always and always be equal to 0. And remember, when r prime of t dot r of t is equal to 0, then their magnitude, that's r prime of t dot r of t, is also equal to 0. Also, remember that if we have a vector and we square it, it's just the same as the vector multiplying each other. That's the magnitude of the vector square is equal to the vector times itself. For instance, the magnitude of 2 squared, a constant, is equal to, let's say, remember we say that this must be constant, the magnitude must be constant. So let's say the magnitude of a vector is the magnitude of a vector is 2. When we square that, is the same as 2 times 2. This square is the magnitude of 4. 2 times 2 is 4. The magnitude of 4 is the same as 4. That's the absolute value of 4 is the same as 4. So you realize that. So we can use this theory to prove a particular question. It's a given that the magnitude of r of t is constant. Is equal to c. Show that the magnitude of r prime of t dot r of t is nothing but 0. If the magnitude of r of t is equal to c, is constant, we should show that the dot product of the derivative of the vector value function and the vector value function, the magnitude of that, or the absolute value of that, is also 0. So how do we solve this? Remember, we said that the magnitude of a squared is the same as a times a, or a dot a. Then we can say that if we have the magnitude of r of t and it's equal to c, we can square both sides. So squaring both sides, on square both sides, we can say r prime of t, the magnitude, the absolute value of r of t squared is equal to c squared. Remember, this will be r of t dot r of t. I'm borrowing that from here, and it's equal to c squared. Now, I need the derivative. How do I get a derivative? So, vector value function are multiplying each other, and we want to find the derivative of their dot product. Remember, we'll keep one, differentiate the other. Then we keep the one we differentiate and differentiate the one we did not differentiate earlier. So we can say we keep r of t dot, we differentiate this r prime of t, then plus, now keep this r of t and differentiate this r of t, we'll get r prime of t. And to be equal to the differential of a constant, c squared is a constant, it is 0. Now r of t dot r prime of t plus r of t dot r prime of t will be 2 r prime of t r of t, and it's equal to 0. I can divide both sides by 2. So I can say our r prime of t dot r of t will be equal to 0. So since the r prime of t dot r of t is equal to 0, we can also conclude that the absolute value of r of t, or the magnitude of r of t dot r prime of t dot r of t, is also equal to 0 as required. So we'll end it here today. Please remember to subscribe to my YouTube channel before you sign off. Please, your comment keep me going. Like my video, share. This will make my YouTube channel grow more, and I can record more mathematical content for you. Until we meet again, my name is TTJ Kepsi Richard.